Welcome back. The objectives of this video is to go through a sample problem using a quadratic function as it relates to average rate of change, and we'll probably see a secant line in here as well. So we have a sample problem here. The graph below gives Nikola Technologies revenue for Bluetooth headphones. The x-axis represents the price of the headphones, so we should label our x-axis with price in dollars. And our y-axis represents the revenue in millions of dollars. So here's our revenue axis in dollars in millions. So looks like some pretty good revenue there. Question A says, at what price will the tech company make no money on the headphones? Well, I'm assuming here that they mean will not generate any revenue. So we're going to correct that. So that would be generate zero revenue. So they generate zero revenue, well, at the x-intercepts. So and those x-intercepts are at the origin, 0, 0, and at $110 per pair of headphones. Apparently they won't generate any revenue there, means nobody's going to buy them. So at 110, 0. So, and our ordered pairs, of course, are price and revenue. So why? Well, I guess if at $0, this means that they would be giving them away for free, and so obviously you don't generate any revenue. And at $110, I would say the price is going to be too high and no one will buy. So therefore they will have no sales. So the price is too high and you will have no sales. So no demand for the headphones at that particular price. Two employees are discussing the best selling price for the headphones. One thinks that $45 per set is best, and the other believes they should sell them for more than $50. Use the graph to analyze this discussion. Well, I would think that the employees of the company, if they're pricing it, would have projections and might have access to something like this, and I'd say both are pretty much on the right track here. If you want to maximize revenue, and we have a quadratic function, the maximum in a quadratic, or the minimum in a quadratic, is going to be the vertex of that quadratic. So our vertex is up here, so the employee that's looking at $50 is per set is looking at 200 or 2,000 million in revenue. 55, that seems a little closer to the vertex. That looks to be about that looks to be our vertex. So I guess we're looking at 45 and 50. So both of them are close at 45 and 50. It looks like our vertex is right around 55. So I would say both employees are on the right path, but they could use math and economics to find the best selling price. The company goal is to have maximum revenue. What would be the best price for each set of headphones? Well, as I've said in B, the maximum implies the vertex, and the vertex is going to fall halfway between the x-intercepts, or in between the x-intercepts. So if we take our x-intercepts of 110 minus 0 and divide that by 2, we're going to get $55. And that appears to generate $2,100 million in revenue. Between price of 0 and a price of 55, how much does the revenue change on average when the price of the headphones increases by $1. This is a question asking for calculate the average rate of change. So let's take a look. We've got a couple of ordered pairs here. When the price is 0, that's 0, 0, and then the price is 55. Again, that appears to be about 2100. Right? We got that in the last question. It's confirmed by our graph. So let's calculate our average rate of change based on our two ordered pairs. And so 2100 minus 0 all over 55 minus 0, so that's going to be 2100 over 55. Put that in my calculator and comes out to $3.38.18 million in revenue for every $1 increase in price. Could there be any factors when the company might adjust or alter the price of the headphone set? Certainly there could be. What might cause them to change the price? Maybe supply chain issues and they can't get parts, or something like that could create some challenges. Maybe a change in technology by a competitor, or competition could create a change in quantity demanded for their product. Maybe a competitor goes out of business and there's less competition, so then they could sell for more. So there's a lot of things that could adjust the price of the headphone set. That's more of an economics question. What's going to impact the demand for the product, or the quantity demanded, or even the supply or the quantity supplied. So, and that wraps up our sample problem using a quadratic and average rate of change, and we'll get some more practice with that when I see you in class.